All right, y'all. We're going to walk through how we would solve these different vector problems from the study guide. So the first problem, we're being asked to calculate the x and y components of this vector. So my recommendation to you would be to redraw the triangle and have the hypotenuse be that 10 newtons. Now, the x and y components, as a reminder, are the parts of the vector that lie along the x and y axes. So we'd have the x component here, and we'd have the y component there. So drawing this all together, we would have these at a right angle. We'd have x here and y here. The angle is 55 degrees. So what we're going to do is, this looks terrible. Hold on. I'm going to change my pen. Okay. So redrawing a little bit clearer. Here's there. 55 degrees, 10 newtons, fx and fy. So we'll start with fx. The x component is going to be the adjacent side of this triangle. So from our SOHCAHTOA, the cosine is going to be adjacent and hypotenuse. Now we know the hypotenuse, we want the adjacent. So cosine of theta is going to be the adjacent over the hypotenuse. So cosine of 55 is going to be the adjacent side, which we're labeling as fx, over the hypotenuse, which is 10. So multiplying by 10 on both sides, we get 10 cosine of 55 equals fx, which is 10 cosine of 55, 5.74. And that would be in newtons. And for the y component, we are going to use sine. So sine is opposite in hypotenuse, so fy would be the opposite side here. So this is the adjacent, and this is the opposite. So sine of theta is opposite over hypotenuse. Sine of 55 is the opposite side, fy, over the hypotenuse, which is 10. Again, multiplying by 10 on both sides. 10 sine 55 is our fy, which is 8.19. And that would again be in newtons. So those would be our x component and our y component. And we do this, as we're going to see in the third problem, because in order for us to add vectors that are at angles to each other, we need to know their x components and y components, because we can't directly add forces that are at angles, but we can add their x components together, and we can add their y components together kind of separately, and then recombine them afterwards. We're going to get there in just a second. But for the next one, give myself some space here. Nope, that's not what I wanted to do at all. Okay. All right, for this one, we are going to combine these two vectors. We have 2 newtons pointing on the positive y-axis and 5 newtons pointing on the positive x-axis. So to add these together, we would do the tip-to-tail sort of addition. So we would take our 5 newton vector, and then we would add tip-to-tail the that's a little bit janky, so we're going to draw at the right length. This would be our 2 newton vector here. And then the resultant, there's that word. The resultant is going to be kind of the combination of those two. And that is going to be, we'll just call that f. And we're also going to want to know what the angle is in here. Let me drop these two down as well. All right. So with our triangle, we have the 5 newtons here. We have the 2 newtons here. This is f, and in here is theta. For the value of the hypotenuse, we can just use Pythagorean theorem. So a squared plus b squared equals c squared. We have 2 squared plus 5 squared equals c squared. 4 plus 25 equals c squared. 29 equals c squared. Then we take the square root, and we find that the hypotenuse, c, which we're going to call, right, we called f, is the square root of 29, or 5.39. And that would be in newtons here. So that would be our hypotenuse, 5.39. Put that there. And now the other thing we have to do is calculate the angle. And we can do that in a couple of ways. We have all three sides of our triangle, so we can use any trig function we want. I'm going to choose to use tangent here. So tangent of the angle is opposite, so TOA, opposite over adjacent. Theta is our variable here. We're solving for theta. The opposite is 2, and the adjacent is 5. So in this case, tan theta, I don't know why it's doing that. Please delete. Tan theta is 2 over 5. I should know this off the top of my head, but I don't. Is 0.4. Now, to get rid of a trig function, we have to use the inverse function. And we would apply that to both sides. As a reminder, tan theta is kind of stuck together. That stands for a number. So if we use inverse tangent of tan theta, that's going to equal the inverse tangent of 0.4. And the same way that we would kind of put the function and the number, just punch that into the calculator, we can use inverse tangent the same way. So the inverse tangent gets rid of the tangent, leaving theta as the variable. And then the inverse tangent of 0.4 is 21.8 degrees. And that would be our angle. So to put this all together, it would be 5.39 newtons at 21.8 degrees. And we can get a little bit more specific. 21.8 degrees specifically from the positive x-axis. So we would go ahead and add that. 21.8 degrees from the positive x-axis. And we have to provide that reference so that we know where we're measuring our angle from. Now we go to the last one, and this is going to be the longest for sure. But what we're trying to do here is we're trying to add all of these vectors together. Now, as previously mentioned, we can't just add the numbers together. We're going to have to figure out their x and y components and then add those together and then kind of squish it all back together. So for, let's see, what can I do here? I'm going to use some colors. So we're going to call this A. If I can write correctly. This will be A. We use purple, this will be B, and then green sounds good. This will be vector C. So we're trying to add A, B, and C, and when we find each of their components, we can then add fxa, fxb, fxc together and kind of bring it all together once we're done with that. Let's do A first. So A, we're going to have the triangle like this. A is, can't write, A is 30 at 55 degrees, and this would be fxa, and this would be fya. To get our two components, we're going to do cosine for fxa. So cosine of theta is adjacent over hypotenuse. So fxa would be our adjacent, and fya would be our opposite. So cosine of 55 equals adjacent, which is fxa, over the hypotenuse, which is 30. So multiplying by 30, we get 30 cosine of 55 equals fxa, which is going to be 30 cosine of 55 is 17.2. Okay, so that's going to be one of the numbers that we need. Let's go ahead and do the other side. We're going to use sine here. So sine of theta is opposite over hypotenuse. Sine of 55, the opposite side is FYA over the hypotenuse, which again is 30. So multiplying by 30, we get 30 sine 55 equals FYA, and that is going to be 30 sine 55 is 24.6. And that's going to be another number that we need, so let's highlight that, and we'll come back to that in a second. Let's do B. So B, we used purple. B, we're going to have our hypotenuse kind of going down this way, and then here are our two sides. So this is 40. This would be FXB. If I can write properly, FXB, that looks like a 13. Write a B, please. There you go. And this is FYB. So this one's going to be slightly different because we're going to have to use different functions here for the two sides. So in this case, since this is our 70 degrees, Fx is going to be the opposite and Fyb is going to be the adjacent. So be careful with which function you're choosing. I would recommend just writing opposite and adjacent on the different sides so that you don't mess it up. So we'll use sine for the x component here. So sine is, again, opposite over hypotenuse. Sine of 70 degrees. I don't know why I wrote the degree symbol. Opposite is Fxb, and that's over 40. Multiplying by 40, we get 40, sine of 70 equals Fxb, and that is 40 sine 70, which is 37.6. So we're going to kind of highlight that and come back to it later. Then we will go ahead and do, do cosine theta is adjacent over hypotenuse. And so cosine of 70, the adjacent side, if we look back at our triangle again, is Fyb. So Fyb, looks like a beta, over the hypotenuse, which is 40. So we multiply by 40. We get 40 cosine of 70 equals Fyb, or 40 cosine 70 is 13.7. And again, we're going to highlight that and come back to that later as well. Switching over to green, we will do our third vector, and that is C. So C, I'm going to draw here. There's our right angle. C is 35, and the angle in here is 40. So our FYC and our FXC are there. FYC is the adjacent, and FXC is the opposite. So we got to make sure we're doing that correctly again. For FXC, that's the opposite, so we're going to use sine. Sine theta is opposite over hypotenuse. So sine of 40 degrees is Fxc over 35 times 35. We get 35 sine of 40 equals Fxc, and 35 sine of 40 happens to be 22.5. Highlight that also. Last would be the adjacent side, which is Fyc. So we would use cosine. Cosine of theta is adjacent over hypotenuse. So cosine of 40. The adjacent side is Fyc over 35 times 35 on both sides. We get 35 cosine of 40 equals, Fyc, and 35 cosine of 40 is 26.8. Okay, so now we have all of our components. So let me zoom out here so we can kind of look at our work. So here we go. We have our x components and we have our y components. So now we're going to add them up. I'll choose, let's use a different color. Let's use blue. Where's blue? Blue. Okay. For our x components, we're going to do, so fx, I'll just call it f, or we could call it a plus b plus c. I'm just going to choose to use x because it's a little bit shorter. So fx is going to be, now we need to pay close attention to the signs. So fxa is going to be positive, so we'll do fxa. fxb is also positive, so we'll do plus fxb. And then fxc is negative, so minus fxc. And then if we pull those numbers, fxa, 17.2 plus fxb, 37.6 minus fxc, 22.5, giving us a total of, 17.2 plus 37.6 minus 22.5 gives us an x component of 32.3. Okay, now for the y components, let's look at what these would be. So fya is positive, so we'll do fya. fyb is negative, so minus fyb. And then if we look once again, fyc is also negative, so minus fyc. The numbers are fya is 24.6 minus 13.7 minus 26.8. And that gives us an fy of 24.6 minus 13.7 minus 26.8. Just checking my numbers, is a negative 15.9. All right. So we're doing pretty good. Now we need to kind of squish these all together. We would have, if we draw ourselves an xy plane real quick, we would have an x component of 32.3 and a y component of negative 15.9. So when we put those together, if I redraw my y component tip to tail, this would be negative 15.9. Then my end result, what's a good color? Orange sounds good. My end result would be this, and that's going to be f. So redrawing my triangle, that's not even close to correct. That looks good. So 32.3, and we're going to leave off the negative sign here. So 15.9, and we'll call that f. So we need to do two things. We need to figure out the actual value of f, and then we need to figure out its angle. So for the value of f, we can use a squared plus b squared equals c squared. We'd have 32.3 squared plus 15.9 squared equals c squared. So 32.3 squared plus 15.9 squared is 1,296.1, and that technically is f, so we're just going to label it f, and take the square root of that, and we get that f is 36. Wow, right on the dot. 36.001, but we're going to call it that. So f is 36. And then for the angle, we can go ahead and use tangent again. So tan theta is opposite over adjacent. Our opposite side is 15.9, and our adjacent side is 32.3. So tan theta equals 15.9 divided by 32.3. is 0.49, and then we apply inverse tangent to both sides. Tangent and inverse tangent cancel, giving us an angle of the inverse tangent of that answer, which is 26.2 degrees. So to wrap all this up, F would be 36 newtons at 26.2 degrees from, now this would be from the positive x-axis is where we measured that angle. So there's theta, and that would be from the positive x-axis. And that, after all of that nonsense, would be our final answer. So hopefully you found this useful. If you have any extra questions, feel free to ask. Email me. Your test is tomorrow, so good luck studying. And yeah, again, email me with any questions.